Hello students, today we will do exercise 3.4 in which we will find inverse of a matrix by elementary transformation. Now before the exercise, we should know about the elementary transformations or operations that can be applied on a matrix. Now there are 6 operations, 3 of which are due to row and 3 due to columns, which can be applied on a matrix, and these operations are called elementary operations or transformations. Now first elementary operation is the interchange of any two rows or columns. Now that means we can interchange any two rows or columns of a matrix. If we are changing the ith row with jth row, then it will be represented by Ri interchanged with Rj, and if we are changing the ith column of a matrix with jth column, then it will be represented as Ci interchanged with Cj. Now let us know this with the help of an example. Now here I have taken a matrix A of order 3 by 3. Now if we want to change the second row, interchange the second row with the third row, then it will be represented by R2 interchanged with R3. Now the R1 row 1, that is 2 3 1, will remain the same, that is 2 3 1 here. Now R2 will be interchanged by R3, that means in place of R2 we will write R3. Now R3 was 3 5 4, so this will come in place of R2, that is 3 5 4. Now R3 will be interchanged with R2, that in place of R3 we will write R2, and R2 was 5 to 6. In place of R3 we will write down R2, that was 5 to 6. Similarly, if we want to interchange column 1 of a matrix by column 3 of a matrix A, then it will be represented as C1 interchanged with C3. Now we have to change column 1 by column 3. So in place of column 1 we will write down column 3, that was 164, and in place of column 3 we will write down column 1, that was 256, and column 2 will remain the same. Now second elementary transformation is the multiplication of the element of any row or column by a non-zero number. So we can multiply the elements of any row or column by a non-zero number. Now if we are multiplying, if we are changing the ith row by multiplying it by any non-zero number k, then it will be represented as Ri changed to k into Ri. Or if we want to change ith column of a matrix by k into Ci, then it will be represented by Ci changed with k into Ci. Now here there is a matrix A of order 3 by 3, and we want to change row 3 by 2 into row 3. So row 1 will remain same, that was 213. Row 2 will also remain same, that was 352. And here we are changing row 3 by 2 into row 3. That means all the elements of row 3 will be multiplied by 2. So that means this will give us 2 into 4, 8, 2 into 6 will be 12, and 2 into 1 will be 2. Now similarly, if you want to change the column 2 of a matrix by multiplying it by 1 by 3, then it will be represented as column 2 changed by 1 by 3 into column 2. Now that means column 1 and column 3 will remain same, as we are not changing them, and column 2 will be multiplied by 1 by 3. That means all the elements of column 2 will be multiplied by 1 by 3. So 1 into 1 by 3 will be 1 by 3, then 5 into 1 by 3 will be again 5 by 3, and 6 into 1 by 3 will be equal to 2. Now the third elementary transformation is the addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. That means that we can add all the elements of any row or column to the corresponding elements of the other row or column by multiplying it by any non-zero number. Now, if we are changing the ith row of a matrix by adding the ith row to the corresponding elements of jth row multiplied by a non-zero number k, then it will be represented by Ri changed with Ri plus k into Rj. Similarly, if we are changing the ith row of ith column of a matrix by adding elements of ith column to the corresponding elements of jth column multiply a non-zero number, then it is represented by Ci changed with Ci plus k into Ci. Now let us take an example. Now here I have taken a matrix A of order 2 by 3. Now if we want to change the row 1 of a matrix by row 1 plus 2 into row 2, then it will be represented as R1 changed by R1 plus 2 into R2. Now this will give us a matrix. Now first row will change with R1 plus 2 R2. That means first element of the first row is 2 and its corresponding element in second row is 3. That means this will be 2 plus 2 into, and corresponding element of 2 in second row is 3. So 2 into 3, and this will give us 8. Similarly, the second element of the first row is 4. Now plus 2 into R2, and corresponding element in row 2 to the second element of row 1 is 2. So this will be 2 into 2. So this will give us 8 again. Now 5. Third element of row 1 is 5. Now plus 2 into row 2, and its corresponding element in row 2 is 6. So that will be 6 to 12 plus 5, 17. Now second row will remain unchanged, that is 3 to 6. Similarly, we can also apply the operation in column. Suppose we are changing the column 2 by 1 by 2 by column 2 plus 1 by 2 into column 3. Then it will be represented by C2 changed by C2 plus 1 by 2 into C3. Now this will give us the matrix as, now first column will remain the same, that was 2, 3. Second column will be changed by second column plus 1 by 2 into third column. Now first element of the second column is 4. Now plus 1 by 2 into column 3. To corresponding element to 4 in column 3 is 5. That means first element of column 3 is 5. So that will be 1 by 2 into 5. That will give us 4 plus 5 by 2, 13 by 2. Similarly, the second element of the column 2 is 2. And this will be added to half into column 3. The corresponding element to this 2 in column 3 is 6. So into 6. So 2, 3 is 6, and that will give us 5. Now the last column, that is column 3rd, will remain the same. So these are the 6 operations, 3 due to row and 3 due to column, which can be applied on a matrix. Now come to invertible matrices. Now what are invertible matrices? If A is a square matrix of order M and if there exists any square matrix of B of the same order M such that product of AB is equal to product of BA, that is equal to identity matrix, then B is called the inverse matrix of A and it is denoted by A inverse. In that case, A is said to be invertible. Now come to some properties of inverse of a matrix. Now uniqueness of inverse, that is inverse of a square matrix if it exists is unique. That means every square matrix has one and only one inverse if it exists. Now let us prove this one. Let A equal to Aij be a square matrix of order M. If possible, let B and C be two inverses of A. We are taking two inverses B and C. Now as we know, the inverse is unique. That means we have to prove that matrix P is equal to matrix C. Now since we have taken that B is inverse of A, that means A into B will be equal to B into A, that is equal to identity matrix. Similarly, we have also taken that C is inverse of A, that means AC will be equal to CA and that will be equal to identity matrix. As we know, if a matrix is multiplied by identity matrix that gives us the same result as that matrix, that means matrix B can be written as B into I. Now I, as in second equation, we see that AC is equal to I. Therefore, in place of identity matrix, we can write matrix AC. Product of AC. Now this will, as we know, the matrix multiplication is distributive. That means this B into AC can be written as BA into C. Now BA is from equation first, the value of BA is equal to I, that means this will be equal to IC, and identity matrix into C matrix will be again C matrix. Now thus we have proved that B equal to C. That means every square matrix has a unique inverse if its inverse exists. Now second one is, if A and B are invertible matrices, there are two matrices A and B, and if they are invertible and of the same order, then AB whole inverse is equal to B inverse A inverse. Now as we know that A into A inverse is equal to I, that means AB into AB inverse will be equal to I. Now on multiplying both sides by A inverse, we are getting A inverse AB into AB inverse equal to A inverse I. Now A inverse A will be equal to I, and that will give us I into B AB inverse, that equal to A inverse I will be again A inverse. Now identity matrix into any matrix give us the result as the same matrix. That means I into B will be equal to B matrix. Now after that, on multiplying both sides by B inverse, now we will get B inverse B into AB inverse equal to B inverse A inverse, as we know that B inverse B is equal to identity matrix. That means if an inverse of a matrix is multiplied to a matrix, then that gives us the identity matrix, and I into AB inverse will be again AB inverse. So this proves our statement. Now come to exercise 3.4. This exercise is very important from the examination point of view. Now here we have to find the inverse of the given matrices if exist by elementary transformation. And question number first, matrix is given to us as 1 minus 1 2 3. I am taking it as matrix A. Now this one is matrix A. Its first row is 1 minus 1 and second row is 2 3. Now we will take A equal to IA and then apply a sequence of row operations or column operations to find or till we get I equal to BA. In this case, B will be the inverse of A. So our first step is we will take A equal to IA. Now matrix A is already given to us, now equal to I. Now identity matrix will be of the same order as that of matrix A. Matrix A was of order 2 by 2, so we will take the identity matrix of order 2 by 2, I into A. Now here we will apply the sequence of operations, row or column operations in left hand side to convert it into identity matrix. Now for our convenience, first of all we will convert first element of row 1, then first element of row 2, then second element of row 2, and at last we will convert the second element of row 1. Now here I am applying row transformation. So for that you must keep in mind that you can't apply the row and column transformation both in the same question. Now we will solve the whole question either by row transformation or either by column transformation. Now here, now we have to convert this A in identity matrix, and as we know the column elements of identity matrix are equal to 1, and here first element of row 1 is already equal to 1, so there is no need to convert it. Now come to the first element of row 2. This one is 2. Now in place of 2, this 2, we have to convert this 2 into 0. Now that means we have to convert row 2, and we know that if we subtract 2 from 2, that will give us 0, and on multiplying 2 to the first row we are getting this as 2. So that means we will convert the row 2 by row 2 minus 2 into row 1. Now here first row will remain the same, and second row, now say R2, first element is 2, minus 2 into R1. Now corresponding element in row 1 of this 2 is 1. Now 2 is first element of row 2. Now first element of row 1 is 1. That means it will be 2 into 1. And this is giving us answer as 0. Again, second element of row 2 is 3. And its corresponding element in row 1 is minus 1. And 3 minus 2 into minus 1 will be equal to 5. Now we'll apply the same elementary transformation which we have applied in left hand side to this identity matrix. Now first row will remain the same. Now second row, this will be R2 minus 2 into R1. 0 minus 2 into 1 will be minus 2. 1 minus 2 into 0 will be 1. A. Now we have to convert the 5, row 2 second element into 1. Now we can't convert it by adding a multiple of row 1 or subtracting the multiple of row 1 from row 2, because that will change the first element of row 2 which we have already obtained. Now if we have already got the required, we have by using elementary transformation, if we have already obtained the required element, then we will not use the elementary transformation which will change that required element. That means we cannot add or subtract the row 2 to the multiple of row 1. So for that we will divide, in order to convert this 5 into 1, we will divide row 2 by 5. On dividing row 2 by 5, we will get this 5 as 1. Or we can say this can also be written as row 2 1 by 5 into row 2. And that will give us row 2 as, now row 2 will be divided by 5 or 1 by 5 into row 2, and that will be 0. 1 by 5 into 5 will be 1. Here row 1 will remain same. Now similar operation will be applied to row 2 of this matrix, and this will be 1 by 5 into minus 2 will be minus 2 by 5. 1 by 5 into 1 will be 1 by 5 into A. Now here, in order to convert into identity matrix, we need to convert this minus 1 into 0. And minus 1 plus 1 is equal to 0. That means row 1 will be converted by adding row 2 to it. Now that means we are converting row 1. 1 plus 0 will be 1. Minus 1 plus 1 will give us 0. And this row 2 will remain the same. Here also 1 plus minus 2 upon 5 will be 3 upon 5. This 0 plus 1 upon 5 will be equal to 1 upon 5. And second row will remain the same. Now we have obtained a matrix in the form of I equal to BA. That means this B matrix will be inverse of A. Thus we can say that that A inverse is equal to 3 by 5 minus 2 by 5, 1 by 5 and 1 by 5. And question number 5, matrix 2 1 7 4 is given to us. Now I have taken it as matrix A. Now our first step is that we have to take A equal to IA and then apply the row transformation or column transformation, any one of these, to find, to convert this in the form of I equal to BA. Then B will be the inverse of A. Now A equal to IA means matrix A was 2 1 7 4. Now I will be the identity matrix. Now the order of the identity matrix will be same as the order of A, as A is of 2 by 2 order, so we will take the identity matrix of order 2 by 2 into A. Now we have solved the first question by row transformation. In this question I am applying column transformation. Now in this case, first of all, we have to convert the first element of row 1 into 1. Now we have to convert this whole matrix into identity matrix. For that, in place of 2 we need 1. So 2 minus 1 will give us 1. That means we will convert column 1 by column 1 minus column 2. Now here column 1 minus, we will change column 1 to 2 minus 1 will be equal to 1. 7 minus 4 will give us 3, and second column will remain the same. Now on the right hand side we will apply the same operation. Now we are changing column 1 by column 1 minus column 2, and the corresponding element to 1 in column 2 is 0. So this will be 1 minus 0, and that will give us 1 again. 0 minus 1 will give us minus 1, and second column will remain the same. Now again, here in place of 1 we need 0 in order to make it an identity matrix. Now 1 minus 1 will give us 0. That means if we subtract column 2 by column 1, then this element 1 will become 0. So we will apply the transformation as column 2. We are changing column 2 by column 2 minus column 1. Now in column first will remain the same in both left hand side and right hand side. Now column 2. Now corresponding element to 1 in column first is 1. So this will be 1 minus 1, and 1 minus 1 will be 0. 4 minus 3, that will give us 1. Here also column 2 will change. Now this will 0 minus 1 will give us minus 1, and 1 minus minus 1, that will be equal to 2 into A. Now it is 1 here, and diagonal elements of the identity matrix are all elements of the diagonal are equal to 1, so there is no need to change this element. Now come to the first element of second row, that is 3, and in place of 3 we need 0, and 3 minus 1 will be equal to 2, but 3 minus 3 will give us 0. That means we can, and on multiplying 3 with the column 2 here, if you multiply 3 to 1, that will give us 3, and 3 minus 3 will be 0. That means we will change column 1 by column 1 minus 3 into column 2. Now first column will remain this, first column will change, that will column 1 minus 3 into 0, that will give us 1. 3 minus 3 into 1 will be equal to 0, and the second column will remain the same. Similarly on the right hand side, now 1 minus 3 into minus 1, 1 minus 3 into minus 1, that will give us 4. Now minus 1 minus 3 into 2, that will give us minus 7. Now this will be, second column will remain the same. Now this matrix is in the form of I equal to BA. That means this B matrix will be inverse of A. Thus we can say that A inverse is equal to 4 minus 7 minus 1, 2. As we know that if an inverse of matrix is multiplied with a matrix, that gives us the identity matrix. Now in question number 12, matrix A is given to us, that is 6 minus 3 minus 2 1. Now our first step in order to find the inverse of a matrix is that we have to take A equal to IA, and we will put the value of A and I, that is identity matrix. Now in this, if we transform row 1 by row 1 plus 3 into row 2, then this 6 minus 3 into minus 2 will give us 0, plus 3 into minus 2. Here we are adding the 3 into row 2 to the row 1, so that will give us 0. Now second will be minus 3 plus 3 into 1, that will also give us 0, and second row will remain the same. On the right hand side, we will apply the same transformation, that is row 1 plus 3 into row 2, and we are changing row 1. So 1 plus 3 into 0 will give us 1, 0 plus 3 into 1 will give us 3, and the second row will remain the same. As we see here, all the elements of row 1 are equal to 0. Now if in any row, if all the elements of any row or any column are all equal to 0, then the matrix is not invertible, or we can say we cannot obtain the inverse of a matrix. Now here, as all the elements of row 1 are equal to 0, so we can say that inverse of matrix A does not exist. Now you have to keep in mind that during elementary transformation, if all the elements of any row or all the elements of any column are equal to 0, then we can say that inverse of that matrix does not exist. Now come to question number 15. A square matrix of order 3 is given to us. I am taking it as a matrix A. Now our first step is we have to take A equal to IA. Now in place of A, we'll write down the matrix A. I will be the identity matrix of order 3 as A is of order 3. Now I am doing it by row transformation. In case of row transformation, we will proceed in the direction as I am showing with the help of arrows. Now this will make our solution error free. Now first of all, we will convert this 2 into 1, as we have to convert this matrix A into identity matrix. So the first element of first row should be equal to 1. As we know, 2 plus 2 minus 3 will give us 1. So we will apply the transformation as R1 change to R1 plus R2 minus R3. Now this will be, as we are changing row 1, so row 2 and row 3 will remain the same. Now in place of 2, we will write 2 plus 2 minus 3, and that will be equal to 1. Now minus 3 plus 2 will be minus 1, and minus 2 will be equal to 1. 3 plus 3 is 6, and minus 2 will give us 4. We will apply the same transformation to the right hand side. Now here row 3 and row 2 and row 3 will remain the same. Now we will convert row 1 by row 1 plus row 2 minus row 3, and this will give us 1 plus 0 minus 0 will be equal to 1. 0 plus 1 minus 0 will again be equal to 1, and 0 plus 0 minus 1 will give us minus 1. Now after converting the first element of the first row to 1, we will convert the first element of second row to 0. Now here, as we know, 2 minus 2 is equal to 0. So 2 minus 2 into 1 will give us 0. That means we have to apply the transformation as R2 change to R2 minus 2 into R1. 2 into R1. Now again, the row 1 and row 3 in both left hand side and right hand side will remain unchanged. We will change only row 2. Now row 2 will be row 2 minus 2 row 1. So 2 into minus 2 into 1 will give us 0. 2 into minus 2 into 1 will again give us 0. 3 minus 2 into 4 will be equal to minus 5. Now here on the right hand side again 0 minus 2 into 1 will give us minus 2. 1 minus 2 into 1 will be equal to minus 1, and 0 minus 2 into minus 1 will be equal to 2. Now after converting the first element of the second row, we will convert the first element of the third row to 0. Now 3 minus 3 is equal to 0. That means 3 minus 3 into 1 will give us 0. That means we have to apply the transformation as R3 change to R3 minus 3 into R1. Here again R1 and R2 will remain unchanged. We have to change only R3 on both left and right hand side. Now we will copy the row 1 and row 2 on left hand side and right hand side from our previous step. Now R3 equal to R3 minus 3R1. So R3 3 minus 3 into 1 will give us 0. Minus 2 minus 3 into 1 will be equal to minus 5, and 2 minus 3 into 4 will give us minus 10. Now similarly on the right hand side, 0 minus 3 into 1 will be equal to minus 3. 0 minus 3 into 1 will be again minus 3. 1 minus 3 into minus 1 will give us 4. Now after getting 0 as the first element of row 3, we will now convert the second element of row 2 to 1. Now, as the diagonal elements of the identity matrix are all equal to 1. Now, in order to convert this into 1, now 0 plus 1 will give us 1, but this will also convert the first element of second row, that will 0 plus 1. Again here it will it will be equal to 1. So now in transformation we should keep in mind that the elements or required elements which we have already obtained should not change. Now if we are adding row 2 to row 1, we are getting 1 as the second element of the row 2, but this is also changing the first element of row 2, so we can't add it to row 1. Now for this, now if we interchange row 2 to row 3 and then divide it by minus 5, then that will give us 1. So we are interchanging the row 2 and row 3. Now on interchanging row 2 to row 3, the row 1 will remain the same, and in place of row 3 we will write down row 2, and in place of row 2 we will write down row 3 in both of the left hand and right hand matrices. Now after interchanging the row 2 and row 3, now we are getting minus 5 as the second element of row 2. So if we divide it by minus 5, this will give us 1, which is required. So we will convert R2 to R2 divided by minus 5, or you can also write R2 converted to 1 minus 1 by 5 into R2. Now as we are changing R2, so R1 and R3 will remain same on left hand side and right hand side. Now here R2 is equal to R2 divided by minus 5, to 0 divided by minus 5 will give us 0, minus 5 divided by minus 5 will give us 1, and minus 10 divided by minus 5 will be equal to 2. Similarly on the right hand side, minus 3 divided by minus 5 will give us 3 by 5. Now minus 3 divided by minus 5 will again 3 by 5, and 4 divided by minus 5 will give us minus 4 by 5. After that we have to check the second element of row 3, and that is already equal to 0. Now we have to convert the third element of the row 3 to 1. Now the last element of the row 3 will be converted to 1 by dividing it by minus 5, as we cannot add or subtract it to row 1 or row 2. That will change our elements which we have obtained earlier. Any of the rows to make it 0. So we will divide the third row by minus 5 to make it 1. That means here we need transformation as R3. We have to transform this row 3 as row 3 divided by minus 5, and this will give us row third as 0, 0, and minus 5 divided by minus 5 will be equal to 1, and this will be 2 by 5, 1 by 5, and 2 divided by minus 5 will give us minus 2 by 5, and first and second row will remain the same. Now after converting the third element of row 3rd, now we will check the third element of row 2, and that is 2 here, and in place of 2 we need 0. Now if we subtract 2 by 2, then it will give us 0. That means 2 minus 2 into 1 will be equal to 0. That means we have to subtract the second row by third row. And also, if we subtract the second row by third row, the first two elements which we have already acquired are not changing. So we can apply this transformation here. Now that means we have to apply, we have to change row 2 by row 2 minus 2 into row 3. That means row 1 and row 3 will not change. Now here row 2, first element of row 2 is 0, minus 2 into row 3. So 0 minus 0 will be 0, remain the same. 1 minus 0 will remain same. Now 2 minus 2 into 1 will give us 0. Now here it was 1. Now 1 minus 2 into 0 will be 1. Now on the right hand side, 3 by 5 minus 2 into 2 by 5. With 3 by 5 minus 2 into 2 by 5 means 4 by 5, and that is giving us minus 1 by 5. So this will be minus 1 by 5. Similarly, 3 by 5 minus 2 into 1 by 5 will give us 1 by 5. And in the last element, minus 4 by 5 minus 2 into minus 2 by 5. Minus 2 by 5 will give us minus 4 by 5 plus 4 by 5. That means this will be equal to 0. Now after applying the operation in third element of row 3, now we will convert the third element of row 1. Now it is 4 here, and in place of 4 we need 0. 4 minus 4 will be equal to 0. That means if we subtract row 1 by 4 into row 3, that will give us 0. And also this 1 which we have already converted is not, this transformation will not have any effect on this one. So we can apply, we can change row 1 by row 1 minus 4 into row 3. That means the row 1 on the left hand side will become 1 minus 4 into 0 will be 1. 1 minus 4 into 0 will remain as 1. 4 minus 4 into 1 will be 0. And other two rows will remain the same. Here also 1 minus 4 into 2 by 5 will give us minus 1 by 5 minus 3 by 5. 1 minus 4 into 2 by 5, that is 1 minus 8 by 5, and that will give us minus 3 by 5. Now 1 minus 4 into 1 by 5 will be equal to 1 by 5, and minus 1 minus 1 minus 4 into minus 2 by 5 will give us minus 1 plus 8 by 5, and that will be equal to 3 by 5. Now second and third row will remain the same. Now at last, in order to convert it into identity matrix, in place of 1 we need 0, and if we subtract row 1 by row 2, then 1 minus 1 will be 0, and the other two elements, that is 1 and 0, are not changing. So we will apply the transformation. We will change the row 1 by row 1 minus row 2, and that will convert the row 1 on the left hand side into 1 minus 0 will remain as 1. 1 minus 1 will be 0, and 0 minus 0 will be 0. Now other two rows will remain the same. The right hand side, minus 3 by 5 minus 1 by 5 will be equal to minus 2 by 5. 1 by 5 minus 1 by 5 will be equal to 0. 3 by 5 minus 0 will be 3 by 5, and other two rows will remain the same. Now it is in the form of I equal to BA. That means this matrix B, if you are taking this as B, this matrix B is inverse of A. Thus we can say, thus A inverse is equal to minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, and 2 by 5, 1 by 5, minus 2 by 5. Now, in question number 16, a matrix is given to us whose first row is 1, 3, minus 2, second row is minus 3, 0, minus 5, and third row is 2, 5, 0. Now, we have to find its inverse by elementary transformation. For that, I am taking this matrix as A. Now, in order to find its inverse, our first step is that we have to take A equal to IA. In place of A, we will write down the matrix A, and in place of I, we will take a identity matrix of order 3 by 3, as A is of order 3 by 3. Now I am doing this question by row transformation. Here, the first element is 1. Now, then next we will take this first element of the second row, that is minus 3. Now, in place of minus 3, we need 0 if we want to convert it into our identity matrix. Now, as we know, minus 3 plus 3 will be equal to 0. So, we can add row 2, 3 into row 1. And minus 3 plus 3 into 1 will give us 0. So, we will use a transformation R2 change to R2 plus 3R1. Here we are changing R2, so R1 and R3 will remain the same on left hand side and right hand side. Now R2 will be R2 plus 3R1, that is minus 3 plus 3 into 1 will be give us 0. 0 plus 3 into 3 will be equal to 9, and minus 5 plus 3 into minus 2 will give us minus 11. Now on the right hand side, 0 plus 3 into 1 will be 3. 1 plus 3 into 0 will be 1, and 0 plus 3 into 0 will be 0. Now after this, we have to convert first element of the row 3, and that should be 0 here. Now we can subtract 2 by 2 to get 0. So 2 minus 2 into 1 will give us 0. That means we have to apply transformation as row 3 change to row 3 minus 2 into row 1. Now here row 1 and row 2 will remain the same. We have to change only row 3. Now on left hand side, row 3 is equal to row 3 minus 2 row 1. So 2 minus 2 into 1 will give us 0. 5 minus 2 into 3 will give us minus 1, and 0 minus 2 into minus 2 will give us 4. Now here on the right hand side, 0 minus 2 into 1 will be equal to minus 2. Now 0 into 2 into 0 will be 0, and 1 minus 2 into 0 will be 1. Now 1 0 0 we have obtained. Now in place of 9 we need 1, because all the diagonal elements of the identity matrix are equal to 1. So in place of 9 we need 1. 9 minus 8 will give us 1. Now if we multiply row 3rd by 8, if we multiply this minus 1 by 8, then that will give us minus 8, and if we add 9 to 8 into minus 1, that will give us 1. So we will apply the transformation as row 2 change to row 2 plus 8 into row 3. Now that means first row and third row will remain the same. We have to change row 2. Now 0 plus 8 into 0 will remain as 0. Now 9 plus 8 into minus 1 will be 1. Minus 11 plus 8 into 4, that will give us minus 11 plus 32, that is equal to 21. Similarly, on the right hand side, 3 plus 8 into minus 2 will be equal to minus 13. 1 plus 8 into 0 will give us 1, and 0 plus 8 into 1 will be equal to 8. Now we have to convert. Now this was 1. Now we have to change this minus 1 into 0, as minus 1 plus 1 will be equal to 0, and 0 plus 0 will not make any change to this first element of row third, which we have already changed. So we can apply the transformation as row 3 plus row 2. So this will be, we are changing row 3 as row 3 plus row 2. Now in this case, row 1 and row 2 on both the sides will remain the same. Now row third will be 0 plus 0 will be 0, minus 1 plus 1 will be equal to 0, and 4 plus 21 will be equal to 25. Similarly, on the right hand side, minus 1 plus minus 13 will give us minus 15, 0 plus 1 will be equal to 1, and 1 plus 8 will be equal to 9. Now, after converting the second element of row 2, we need to convert the third element of the row 3. After second element of row 3, we will convert the third element of the row 3. Now this is 25. As we have seen in earlier questions, the last element is always of the row third is always converted by dividing it by the same number. It is 25, and in place of 25 we need 1 in order to make it an identity matrix. So we will divide it by 25. So here we are using the transformation row 3 change to row 3 divided by 25. So all elements of row 3 will be divided by 25, and the first and second row will remain unchanged. That is 0 divided by 25 will be 0, 0 divided by 25 will be 0, and 25 divided by 25 will give us 1. Here minus 15 divided by 25 will give us minus 3 by 5. Now 1 divided by 25 will be 1 upon 25, and 9 divided by 25 will be 9 upon 25. Now after converting the third element of row third, we need 0 in place of 21. Now for this, 21 minus 21 will be 0. That means 21 minus 21 into 1 will give us 0. So we will change row 2 by row 2 minus 21 into row 3. Now row 1 and row 3 will remain unchanged. In row 2, 0 minus 21 into 0 will give us 0. 1 minus 21 into 0 will be 0, and 21 minus 21 into 1 will be equal to, this was 1. 1 minus 21 into 0 will be equal to 1, and 21 minus 21 into 1 will give us 21. Now on the right hand side, minus 13 minus 13 minus 21 into minus 3 by 5. Now this will be minus 13 plus 63 by 5, and this will give us minus 2 by 5. 1 minus 21 into 1 by 25 will be 1 minus 21 by 25, and that will be equal to 4. That will be equal to 4 by 25. Now our last element of the second row is 8. 8 minus 21 into 9 by 25 will give us 11 by 25. Now this one was 21 minus 21, that will give us 0. Here it was 0. 21 minus 21 into 1 will be equal to 0. Now we have converted all these elements. Now after third element of row 2, now we will check the third element of row 1. It is minus 2. In place of minus 2 we need 0. So minus 2 plus 2 will be equal to 0. So minus 2 plus 2 into 1 will give us this element as 0. That means we have to apply the transformation as row 1 minus plus 2 into row 3. Now we are changing row 1 here, row 1 by row 1 plus 2 into row 3. So 1 plus 2 into 1 plus 2 into 0 will be 1, 3 plus 2 into 0 will be 3, minus 2 plus 2 into 1 will give us 0. Other two rows will remain the same. On the right hand side again 1 plus 2 into minus 3 by 5 will be equal to minus 1 by 5, 0 plus 2 into 2 by 25 will be equal to 2 by 25, and 0 plus 2 into 9 by 25 will give us 18 by 25, and other two rows, second and third row, will remain the same. Now in order to convert this into identity matrix, we need 0 in place of 3. 3 minus 3 will be equal to 0. That means we have to apply row 1 change to row 1 minus 3 into 3 into 1 will be 3. So row 1 minus 3 into row 2, and this will give us on the right hand side the identity matrix, and on the left hand side we have to change row 1 by row 1 minus 3 into row 2. That means row 1 minus 1 upon 5 minus 3 into minus 3 by 5. So that will give us minus 1 by 5 minus 3 into minus 3 by 5. So that will be minus 1 by 5 plus 9 by 5, and this will be 8 by 5. Sorry, we are using here R1, change to R1 minus 3 into R2. R1 minus 1 by 5 minus 3 into minus 2 by 5. So minus 1 by 5 minus 3 into minus 2 by 5 will give us minus 1 by 5 plus 6 by 5, and that will be 5 by 5, and that equal to 1. Our first element is 1. Similarly, second element 2 by 25 minus 3 into 4 by 25 will give us minus 2 by 5, and 18 by 25 minus 3 into 11 by 25 will give us minus 3 by 5. Other two rows will remain the same. Now that means here it is in the form of I equal to BA. That means this matrix B is inverse of A. Thus we can say A inverse is equal to the matrix B. In question number 17, a matrix of order 3 by 3 is given to us and we have to find its inverse. I have taken it as matrix A. Now on taking A equal to IA and putting the value of A and identity matrix, we are getting the matrix as 2 0 minus 1 5 1 0 0 1 3 is equal to identity matrix of order 3 by 3 into A. Now here we can proceed in. Now first of all we will use the pattern. First of all, we'll convert this element, then this one, and then we will convert the middle element, then second element of the third row, third element of the third row, the third element of the second row, then third element of the first row, and then at last second element of the first row. Now here if you see, if you want to convert the second element, first element of the first row, now in order to make an identity matrix, this should be equal to 1 and it is 2 here. Now we can solve it in two ways. First one is that we can write that R1 is interchanged with R1 3 into R1 minus R2. That means this will get 3 into 2 will be 6 and minus 5 will give us 1 here. Also, first we can interchange the row 1 and row 2 so that the 5 comes to becomes the first element of the row 1, and then 5 minus 4 will give us the first element as 1. So I am applying the transformation as row 1 interchanged to row 2. Now you can apply this transformation also, that R1 change to 3R1 minus R2. So row 2 will become row 1 and row 1 will become row 2. That means row 1 will be 5 1 0 and row 2 will be 2 0 minus 1. Similarly on the right hand side, row 1 will be 0 1 0 and row 2 will be 1 0 0. Now after this we need 1 in place of 5. Now 5 minus 4 will give us 1. That is 5 minus 2 into 2 will give us 1. That means we have to apply the transformation R1 change to R1 minus 2 into R2. And this is giving us row 1 as 1 1 2. And on the right hand side row 1 as minus 2 1 0. Other two rows will remain same. Now after converting the first element of first row, we have to convert the first element of second row, that is 2 here, and in place of 2 we need 0 in order to make it an identity matrix. Now 2 minus 2 will be 0. That means 2 minus 2 into 1 will give us 0. So we will apply the transformation as R2 change to R2 minus 2 into R1, and the first and third row will remain the same in left hand side and right hand side, and this second row we will change the second row by row 2 minus 2 row 1, and that is giving the row 2 as 0 minus 2 minus 5, and here row 2 as 5 minus 2 0. Now after second element of row 1 we have to change the first element of the row 3 into 0, and that is already 0. So there is no need to apply any operations in it. Now next step is we have to change the second element of row 2. Now this is minus 2 here, so in place of minus 2 we need 1. That means minus 2 plus 1, or you can say this will be done by interchanging the row 2 by row 3. If you interchange these two rows, now the elements we have already obtained, the desired elements of the first column will not change now, and this one will become the second element of the second row, and that will fulfill our desire. So we will change row 2 to row 3. Now after interchanging row 2 and row 3, we have got 1 as the second row second element, and in an identity matrix the all diagonal elements are equal to 1. So now we will convert this minus 2 into 0. Now minus 2 plus 2 will give us 0. That means we can change row 3 by row 3 minus 2 into row 1. Now this will give us row 1 and row 2 will remain the same. Now this will give us row 3 as 0 0 1, and here on the right hand side the row 3 will become, we are changing row 3, so it will become 5 minus 2, 2. Now after second element of the second row, third row, now we need to check the third element of the third row, and that is already equal to 1. After that we will see the third element of the second row, that is 3, and 3 minus 3 will give us 0. Now in place of 3 we need 0, so we will change row 2 by row 2 minus 3 into row 3, and that is giving us row 2 as 0 1 0. And here on the right hand side the row 2 is minus 15, 6 minus 5, and first and second row, third row will remain the same. Now we need to convert this 2 into 0. 2 minus 2 will give us 0. That means row 1 can be changed by row 1 minus 2 into row 3. This is giving us our desired result. So on changing R1 by R1 minus 2 into R3, we are getting the row 1 as 110 on the left hand side, and on the right hand side row 1 as minus 12, 5 minus 4, and row 2 and row 3 will remain the same. Now there is only one element left, that is second element of row 1, which we need to convert into 0. Now in place of 1 we need 0, and 1 minus 1 will give us 0. That means we will convert this row 1 by row 1 minus row 2, and that is giving the identity matrix on the left hand side, and on the right hand side we are getting a matrix 3 whose first row is 3 minus 1, 1, and other two rows are same as in the previous step. Now as this has been converted into the form of I equal to BA, and as you know, if the inverse of a matrix is multiplied to a matrix, that gives us a identity matrix. That means this matrix B is the inverse of A. Thank you.